We're here at gotomath.com. Getting a headache? No. Looking at some optimization. Let's see. What did I just do? Find the maximum value of rectangular solid with square base. Yeah. Oh, you know what? I think I left off the meters squared. That needs to be a caret right there. We're doing 5-2 rectangular solid square base combined length and girth. Okay. 5-2 is what we're doing. Whoa. Round to 3 decimal place. Rectangular solid with a square base has a combined length and girth of 222 meters. Find the maximum volume of the solid. We are maximizing volume. Max volume. Alright, a rectangular solid with a square base. So this is a lot like 5-1, except there's been, and I think we're going to go ahead and use H for the height. Has a combined length, so H plus, and the girth, which is the girth, X plus X, that'd be 4X. That's what I wrote for girth. 222 meters. Okay, the girth is 1, 2, 3, 4X. Alright. It's been a while since I've done these problems, so since I programmed all this stuff. So we're trying to maximize volume. First, I guess I'll draw a picture over here. This is like a postal problem. Hearing a strange noise outside. Might have to pause the video and check that out. Sounds like there might be a UFO flying over the house. Hearing a humming noise. Hold on just a minute. Okay, and check on that. Turned out I didn't see anything and the humming noise went away. So I guess it abducted an animal out there and then took off. Who knows? I mean, those things are real. I'm not kidding. I actually did see a flying something went straight up into the sky about 5 miles in 1 second. I am not kidding. What are we doing here? We are maximizing volume, I believe. Yeah, I seen one of those things with my own 2 eyes, and I don't know who's got that technology, but if it's coming from planet Earth, man, I'm telling you, it is incredible. I mean, there's no way they got somebody in one of them things. H, the height, times, what are we doing? Volume, so we have X times, so that's X squared. Yeah, I really did see something fly straight up into the sky one time, about 4 years ago. And that is amazing. I don't even know. The girth. What was the girth again? The girth. Okay, this is the girth. The girth is the distance around. Okay, the distance of this side plus this side plus the back side plus this side here. So it's, think of the perimeter here. It's x plus x plus x plus x. All right, and that's the girth. So we have 222. Were we using meters? I can't remember. Anyway, got caught up on the flying saucer thing. So a combined, I gotta go back. Combined length and girth. Okay, got it. So actually, this is the length right here, and I'm calling it H. I don't know. Whatever. H plus the girth. So that was, I said that was 4x. Okay, so we got our setup now, and we want to maximize the volume. All right, it's no big deal. So let's just go ahead and solve for h in this problem. So h is equal to 222 minus 4x. And now we'll take our h, plug it in right here, get everything in terms of x. So our volume is equal to minus 4x times x squared. Let's go ahead, distribute this x squared across. Minus 4x cubed. And now we take the derivative. So we end up with 4, 4, 4 x minus 12x squared, right? 3 times 4 is 12. Okay, we set this equal to 0. And remember what we're doing. We're finding that critical number. Alright, and what I'm going to do here is I'm just going to go ahead and factor out. Let's do this. Let's see, 444 divided by 12. Is that anything good? Yeah, actually it is. It's 37. So I'm going to factor out an x and a 12. Okay, I should have put the 12 over here, but so this ends up being 37 minus, and then this just ends up being x, right? So we can just look at this now and say, oh, well, the solutions are 0 and 37. Well, obviously we're not going to use 0, right? So we're going to use 37 is obviously it's going to be 37. So x is 37. So h is equal to 222 minus 4 times 37. We'll put a parentheses around that. Alright, so that'll get over our h. 222 minus 4 times 37, and you get h is equal to 74. And find the maximum volume of the solid. I kind of skipped that on the last problem. So we just plug everything in. So we got 74, so we got some nice numbers here, actually, which it says round your answer to 3 decimal places. So that makes me skeptical when I see things like that. Oh my gosh. Where are we at? 37? 37 squared. Volume equals, and remember we are using meters. We are using meters, so we want to make sure, right? And this is actually volume, so this is going to be cubic meters. Don't mess that up. So we have 74 times 37 squared. Let's see, squared, yeah, volume. Okay. And we end up with 101,306 meters cubed. Okay. All right. And okay, so looks good, I hope. And I'll go in here and adjust the this thing here. I got a nice function to deal with that. So this will be a little different next time you see it. But anyway, so we set this up. That all looks good. Height times 4x, da 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 da. And of course, we have x is approximately, now don't worry about these zeros here, I'll fix that. But x is 37 meters, and that's what we got. And then 74 was for the height. I actually did use h. And then of course we had 101,306, and like I said, don't worry about all that. Meters cubed, and there it is. Okay, so there we go. Sorry about the flying saucer hold up. Hopefully they won't come back, then people scare me. Alright, so we're at gotomath.com. You want to check that out, and I shall see you